All right, let me just share this to the chat, and there we go. Let's get started in here. All right. So, AC theory level 1, whenever we got to it, was the first real... Now I'm guiding my browser over to that, because I'm not really putting a whole lot in the Socrative today, because it's all stuff we've gone over. You can review my past videos. I think I have them up still. In any case, I'll put the past videos up after this stream. So if you look, AC theory level 1 is a few things to do with inductance. How to calculate inductive reactance primarily is the big thing. How to do inductance in series and parallel. And what inductance is. And then the second half of it is the same things, but with capacitance. Remember your formulas? Let's see. Your formulas are x of L equals 2 pi FL, and L is the same. So combining inductance is the same as combining resistance. L is measured in henries, and X of L is measured in ohms. And then you get X of C. X of C is the opposite of X of L. So you get 1 over 2 pi F C. So 1 over 2 pi FC. And then when you're working with C, it's the C is the opposite of R. C is measured as capacitance, and it's measured in inductor. Henry C is... Ah, shoot. How did I forget the word? It's important. C is microfarads. It's farads. Measured in farads, and X of C is ohms. And this is L and R are the same in series and parallel. C is the opposite of R. So capacitors in series are it's reciprocal method. So 1 over C1 plus 1 over C2. C in parallel is C1 plus C2. So that is, and then L, it works exactly like R. L in series is just adding together, and C in series, or L in parallel is reciprocal method. Okay, and that's that's kind of all the hard parts that you need to know. There is still the little trivia bits, like which leads, which lags, and all of that. That's some things you can look up or will be in a Socrative. All right, so a circuit has a 120 volt 60 hertz source. There are 3 inductors with values of blah 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 connected in parallel. So it's inductors in parallel. Well, we're going to combine them using the reciprocal method. I didn't put an explanation, but we'll combine them using the reciprocal method. Use the 2 pi FL formula to convert that to ohms, and then divide 120 by that. So let's 880. Is that it? 880. So 8,880. So we're going to plug all of our henries into a reciprocal method. So that's 1 over 8 henries. Now these other 2 are given in millihenries, so you have to move the decimal 3 times. And that'll be 800 will be 1 over 0.8 henries. And then 80 will be 1 over 0.08 henries. So let's use our calculator. Drag it over here. Open parentheses. 8 negative 1 plus 0.8 to negative 1 plus 0.08 to negative 1. Close it. Inverse 0.072. That checks because you should come out with henries smaller than your smallest amount of henries. So that's 0.072 henries. So now we need to plug it into this x of L equals 2 pi FL. What is F? What is our frequency? 60 hertz. So x of L equals 2 pi 60 times 0.072. That's henries. So let's plug all that in. Move it over here. 2 times pi times 60 times 0.072. 27.14 ohms. So we got all right, so now we need I is equal to 120 over 27.14 ohms. That's volts. That's from the question. Let's move back over here. Is it behind my head? No, it's not. Okay. Some of it is, but not the important bits. So 120 divided by 27.14, 4.42. Amps. All right, and 4.42 amps is the answer that we got. Good job, the 47% of you. All right. 3 coils with inductance values are connected in series. A 24 volt signal is applied to the circuit. What is the current? Same question. The only difference is the very first step where you add these up instead of doing the reciprocal method. So this is a significantly easier question. Getting 2.2 milliamps. All right. A 24 volt source is driving 12 milliamps through an inductor at 100 kilohertz. What is the inductance of the inductor? This is a good one. I like this. So we got 24 volts, 12 milliamps, and 100 kilohertz. So we have, I keep forgetting the numbers. 24 volts, 12 milliamps. 0.012 amps after you move the decimal, and they want L. So we will 24 divided by 0.012. It's gonna be like 0.05. Clear. 24 divided by 0.012. 2000. I was so wrong. Okay, so now we have 2,000 ohms. So we know 2,000 ohms, that's 200, is equal to, this is X of L equals 2 pi FL. And we know F, it's 100,000. Wow. So 2 times pi times 100,000 times L. So we need to get L by itself. We do that by dividing both sides by 2 pi 100,000. By 2 pi 100,000, I can help us. We'll do it the long way. So, clear. 2,000 divided by, open parentheses, 2 pi, 2 times pi times 100,000, close parentheses, equals 0.00318. So X of L, or no, L, 0.00318 equals L, and that is henries. Let's see if that is an option. 3.19 millihenries. That is our best option. And that's the answer. So good job. 33% of you that got it right. All right. Timing. This one. This was on the actual test that y'all had whenever we went through this the first time. We went through this one a lot. So, paint. Select all, delete. Paint. All right. 100 microfarad capacitor is wired in series with a variable resistor and a timing circuit. What value of resistance must be set for the capacitor to be considered fully charged in 2 seconds? So, in this, fully charged is, fully charged is 5 time constants. So full charge is 5 time constants, and full charge is 2 seconds. So, in our formula, T equals R times C. R times C? Yeah. T equals R times C is 1 time constant. So we need to go 2 divided by 5 is... I don't know what 2 divided by 5 is. I'm drawing complete blank. Divided by 5 is 0.4, just like I said. So that's 0.4 seconds. So we have 0.4 seconds is equal to R times, what's the capacitance? 100 microfarads. So 100 microfarads is 100, and then we go 1, 2, 3, 4, 5, 6. Micro is minus 6. So 0.0001 times 0.0001. Now to get R by itself, which we're looking for R, to get R by itself, we're going to divide by 0.0001 and divide by 0.0001. And that was farads. That's farads and that's farads. This and this cancel. So 0.4 divided by 0.0001. 4,000. And so R is all that we're left with, and it is equal to 4,000 ohms. Survey says 4 kilo ohms. Remember, kilo means 1,000, so that's 4,000 ohms. And last, what is the current through a 500 microfarad capacitor when the applied voltage and frequency is 60 hertz? Easy. Let's get us a new sheet. So, remember from the beginning of this lesson, x of c equals 1 over 2 pi fc. Uh, 60 and 500 microfarads. So xc is 1 over 2 times pi times 60 times, now 500 microfarads is 1, 2, 3, 4, 5, 6. And that is 0.0005. All right, now all we have to do is throw some parentheses around here and plug it into the calculator. So that is clear. 1 divided by, open parenthesis, 2 times pi times 60 times 0.0005. Close your parentheses and hit enter. Let the calculator do the work. We have x of c is 5.3. ohms. And that gives us 120 volts. We're looking for current still. Okay. 120 volts. So we're looking for current. That is 120 volts over 5.3 ohms. I is just under 20. Would it be just over 20? I don't think so. 120 divided by 5.3. 22.64. Wrong on the math again. 22.6. And that's it. All right, let's get that next quiz up. AC Theory Level 2. All right. Starting the quiz. And I'm going to end the stream here. Thank you guys for joining me.